Hello and welcome to the video tutorial walkthrough. Today we're going to be doing the DIY circuit Octave Fuzz. I'm going to go through each steps, give a little bit of information, some education on it, build along with you guys, and talk about it from start to finish. And we're going to have a fully working Octave Fuzz at the end of this. So let's get into it with step one. Alright, so for step one, just like every other build we have, we're going to start with some power filtering just to help the incoming voltage, clean it up a little bit, condition it. So we're going to go to step one, and we're going to start with our polarity diode, which is going to be set up in a flyback manner. So any incorrect voltages coming in will be able to be shunted to ground so it doesn't affect the circuit. Now once again, I'm going to be clipping the leads a little bit shorter, just like in previous videos, to help with some breadboard connections. So let's put our diode in first, according to our build guide. It's going to seem like it's backwards because the negative is into the positive rail, but that's actually going to detect if you've got the wrong polarity, and it's going to shunt it to ground to help protect the circuit. Next we're going to do our 47N capacitor in the rail. These are not polarized, so you don't have to worry about a positive negative. But our C3, actually our C1 is polarized. This is our 100U. We need to make sure that we're doing the positive into the positive and then the negative into the negative. To tell the negative, we're just going to want to look for this strip here. So that strip on the electrolytic is showing our negative, so that's going to go into the negative channel. We're going to do it just like that. Now these are spread out specifically because of the incoming build, and we're going to jump to that with step two right now. Alright, so let's jump to step two. That's going to be our input step and our first transistor, or Q1. So this is going to be setting our impedance. We're going to set our input cap, and we're going to go to Q1 for this, and we'll talk a little bit more about that. So first, to get to the breadboard, we want to jump from the input female pins into the audio area. Again, the audio area is going to be referred to as this area. We got our channel divider here, then we've got our power buses on the top and the bottom. Power is connected via here, and the audio is connected here. So first we jumped into our audio area. Let's go to our first resistor, which is a 1 meg. Remember, the card in the component bag has your cheat sheet on how to read them. You can also use the internet here. There's also plenty of great apps out there where you can, type in the colors or select the colors, and it'll tell you what the value is as you guys are learning how to read them a little better. Alright, so first thing we're doing is we're going to throw R1. That's our pull down resistor. That helps potential popping on toggles or foot switches in a pedal. It's also setting our input impedance for the circuit. Now next we're going to be going to C2. C2 is our input coupling capacitor. It is a 0.22U, so it's a large one. Traditional like fuzz faces and green ringers like this will often have actually an electrolytic reverse polarized for the input, but for this one we're using a film cap of just a very large value. So C2, our input coupling cap, that's going to essentially prevent DC, allow AC to go through, like a guitar pickup, and it's also going to set how much bass is going to be able to be introduced into the circuit. Now that we have C2 placed, we need to go to Q1. So as I mentioned in previous videos, op amps and transistors are kind of like the core or the heart of stuff. So a lot of times I'll like to build around them. Ancillary parts are going to go around these like main core items or main semiconductors. So we're going to bend our legs a little bit like this so that we can get into the breadboard rails a little easier. And let's see, we are going to be going right around here. I'm following along with the build guide that you guys will have either printed out or digitally, so that this will look very similar, if not spot on, to what you guys are doing. Alright, so now that we've got Q1 there, we're going to need to jump over to it with a little bit of green wire. So we're going to go from the side of the cap that's not connected to the in over to our base. Now this transistor is a 5088. That's going to be emitter, base, and collector if you're looking at the flat side, which is a pretty standard pinout for most TO92 package BJTs. So we want to jump to the base. That's the middle one. So we're going to go like this. We're going to go from here to there. And again, greenies and stuff like that are really good when you're working in a more confined area. Alright, so there we go. We've got from our cap to the base of Q1. Now, let's give this some power. Let's get our last resistor here. We're going to snip this a little bit shorter. Just like this. And this is going from our 9-volt rail to our collector to give it power. So our collector is going to be the left leg from the perspective of us, the builder. And again, just follow along with the build guide. But what we're going to do, let's see, we need to move this a little bit. What we want to do is we want to get power distributed to the collector here. So we're going to do that with R2, which is a 10K. We're going to go from power to that collector, and there we go. Next, what we want to do is on the other side, we want to get our emitter to ground. So there's no resistor here. We're going straight to ground, just like in classic fuzz face orientation. We're going to get the emitter, which is our right leg, from the perspective of the builder here. And that, we're going to go with a little bit of black wire. We're going to jump right to ground. Just like that. Alright, so we're almost done. All we have left in this step is a feedback cap that's from our collector to our base to help attenuate some high frequencies. For that, we're calling on a 470 pico, which is our C4. And that's simply going to be jumping between our collector here and our base in the middle. So for following along with the guide, we're going to take this little guy here. We're going to place it between those two legs. There we go. So now that guy is connected between the collector and our base. Alright, so that's going to be a wrap for our input stage, and next we're going to go to stage 3. Alright, so for step 3, we're going to be doing our second transistor, Q2, and we're going to be doing the octave network. So we've got some wire, we've got the transistor, a couple resistors, and we've got our diodes. So now this is going to be a unique transistor for DIY because this is actually going to be a PNP, not an NPN. We're not going to get super into the weeds on that. You can kind of think of it as opposite of NPN, the PNPs. For this instance, we're going to build it and kind of explain a little bit of what it's doing. not necessarily Y. So we need to get our next transistor, and again, we're going to kind of build around the transistor as the core. So let's place that into our breadboard here. Place that one right here. Alright, so now we've got our collector is now on the right, which is the opposite of this guy. So what we're going to need to do is we need to get power to this. Now this is a 3906. If you were going to build this on your own, you could get something like a 2N5087 is also a PNP. We're using the 3906. That's a pretty common market PNP transistor. Let's get power here. We're going to be going from our 9-volt rail, and we're going to be going to the collector. So follow along with the guide, and we're essentially going to be going from our hot rail to the collector, which is the right leg from the builder's perspective. So let's grab our 3. That's a 10K. Again, we're going to cut it down a little bit. Like this. And we're going to go I'm sorry, actually, I gotta follow my own guide. The collector is still the left leg for the builder. So it's got the same pin out on the flat side, emitter-based collector. When in doubt, let's just follow the guide, take my own lesson. So, we gotta go from the hot rail, still gonna do the same thing, it's just a different pin here. So, we're learning on the fly, we're learning together. This is really what this is all about. Also, these minor things happen all the time where the pinouts are backwards or we look at it backwards. So what we want to do is we want to get from our hot rail here. We want to jump over to the left leg from the builder's perspective. We're going to do that with our 10K. Now we've got our 10K distributing 9 volts to our transistor. We have a balanced 10K on the other side. I'm gonna cut this just like the last one. This is R4 that we're talking about, and we need to get this one to ground. So we're going to have the right leg of the transistor for Q2 from the perspective of the builder, jumping over to ground. Do that just like this. Alright, great. So now we have power and ground going to Q2. Now here's where the fun is, because we're going to be going to the diodes right after we get to the transistor. So let's take a quick step back to Q1. We need to go out of the collector of Q1 into the base of Q2. So we're going to do that just like this. Go. So now we've made our connection from Q1's collector over to Q2's base. Alright, so now what we're going to do is we are going to be going out of Q2, our emitter and our collector. We're going to be jumping the channel here with our diodes. Alright, so we're going to jump the channel with our diodes out of the emitter and the collector on Q2. We're going to cut our diodes a little smaller on the legs. we're going to go out the anode through the cathode. So we want to go out the positive of the diode across the channel. The negative will be connected to the channel on the other side. There's our first one. Second one will follow suit. Cut our leads a little smaller. Again, so our anode is going to be with no stripe, and the cathode is with the stripe. So that's our positive, that's our negative. Positive side is going to go into the transistor side, and the negative is going to jump over the channel, just like that. So this is going to be where our waveforms are splitting, and it's going to get doubled, and that's going to actually create that high octave sound that we hear. So now what we've got to do is we actually have to get the cathode or the negative sides of those diodes back together. Now that we've split the form, we're going to come back together. We're going to do that with a little bit of wire. Simply jump it like this. There we go. Alright, so now those are back together, and for the next step, we're going to be going to our Q3 in our fuzz second stage of our gain here in just a sec. Alright, so let's pick up where we left off, and we're going to go to step 4, which is our second stage, our third stage, but it's our second gain stage here. We're going to have some wire, some components, and we're going to have our fuzz control knob for this stage. So now this is really where it's going to start taking shape on this circuit, and we're going to notice something. If you haven't already, I'll point out. So, where we left off, we came out of our, essentially the octave network on Q2 through these diodes. We've jumped together, and now what we got to do is we got to get to the base of Q3. Now Q3 is our standard NPN. We got another 5088 transistor here. Just like the last ones, we are going to get our legs a little bit more apart. And we're going to jump into the breadboard like such. So I tried to design these breadboards to have a good flow, try to be very approachable, similar structures, so all of the transistors are in the same orientation to try to help the builder. It also helps having a clean breadboard so that when you actually come back to it months or even a year later, it might be a little easier to read, because this is kind of like our version of hieroglyphics. So being able to understand it's going to be a lot better, less wires, less ratness and jumping. Okay, so we want to go out of our diodes, we want to get into the base. Now remember, we got emitter, base, collector. The base is in the middle. What we're going to do is we're going to grab a little bit of green wire, we're going to come out of the diodes, and we're going to go to the base of this transistor. Now either of these will work, they're both the same thing. We are going to go like this, simply to the base. Alright, so what we're going to do next, we're actually going to go, I usually go from the collector first. We're going to go to the emitter first, because that's actually going to be our feedback loop and connect our fuzz control knob and feed the circuit back to the front. So what we want to do next, we need to get part of the emitter back to the beginning of the circuit. We're going to do that with some blue wire and R5, which is a 220K. So we're going to be following along underneath here and get back to this side of the capacitor. So we've got a few pieces of blue wire for this build. Let's actually go to the capacitor first. We're going to jump this channel here. Like that. We're going to jump over once more, like this, and that's going to give us a little bit of a segue into the next component. So for this next one, we want to find our 220K. 2.2, 220K. All right, so we've got our 220K. And we're going to snip our leads as usual. This is R5, and this is our feedback network. If you haven't already noticed or picked up on it, minus the octave transistor area, it's a fuzz face to an extent. I've added a bass control, but we're going to get there after. Alright, so we've got our 220K in here. We've got one more jumper that we need to do. We're going to jump it over these green ones, or right behind them, I should say. And then, for the last jump, we have to go to the emitter. So, the emitter on Q3 is going to be this right leg from the perspective of the builder. Just like that. Get some greens to help us out. And there we go. So I made these all blue so that it helps the eye. So if we look at our schematic, we're going to be going from that input capacitor through a 220K to the emitter of Q3. And that's actually followed along here. Even if you lose the wiring a little bit to the eye, the blue one is what we're doing here. From that input capacitor all the way to the emitter of Q3. Alright, so we're not done there. What we got to do is we actually have to jump over to the fuzz control. This is going to be done with cap C6 and our fuzz control, and essentially it's going to be a bypass cap to ground, and that's going to give us our fuzz amount on and our feedback on Q3 going to Q1. So what we got to do is we have to jump our rail, because we don't have enough room on this side right now for the potentiometer. So we have to jump the channel just like that. Again, quick reminder, this channel makes it so that the top and the bottom parts don't touch. Alright, so now that we've jumped across the channel, we're going to be putting our potentiometer in. This is the classic fuzz face style, so it's a 1K value. A little bit, give us some more room. And we're going to leg 3 of the fuzz control. And next what we got to do is we want to go out of 2. So, leg 2 is going to get the positive side of our electrolytic capacitor, and leg 1 is going to get the negative. So we're going to do that just like this. And again, remember, negative side has that stripe on it. There we go. Now all we have left to do is get leg 1 of our fuzz control to ground. To try and keep it elegant, we're going to jump over a little bit, and then we're going to jump up to the ground rail. Now for consistency, we've kept the ground connections with black wire. Alright, great. Last thing we have to do is distribute power to the collector of Q3. We're going to be doing that with R6 and R7. That's a 1K through a 2.2K. So let's find our 1K. Let's cut our leads as usual. now we want to get to the collector. So actually, let's stop here because this build, the way that I've got this designed, it's actually better to go to R7. So let's find our 2.2. We've prepped our 1K here. Let's get our 2.2K, cut that as well, because we're going to be going out of that, the way that this breadboard is laid out. So we're going to go out of that, just like this. So you see we're going out the collector here, through that 2.2K. Now we're going to grab our 1K and get power from the power rail. Great. That's a lot easier. And that's where we're going to stop for this step. And we're going to be going next to our tone control for step 5. Alright, so we just finished step 4. We're going to be going to step 5, which is a tone control, which is actually a high pass filter. As most of you probably know, there's no tone control like this on a classic tone bender 1.5 or fuzz face. I thought it'd be a fun addition here to get more low frequencies out of the circuit to try to help embellish the higher frequencies in that octave that you were going to hear from Q2. So let's jump right into step 5. We've got some wire, we've got a capacitor, we've got a resistor, and we've got our tone control, which is a B25K. So where we left off, right here at this junction for from Q3. That's the collector. So we want to jump out of that to C5, which is the same value as our input cap. Our output cap is going to be a 0.22U. We're going to cut that a little bit shorter. And we're going to be prepping that so that we can get some wire first to kind of give us more area. We could go right away to it, but we've got a little bit more room to work. So we're going to jump. Let's keep this straight that way. We're going to jump from this voltage area to our 2.2U. Then with another piece of green wire, we're going to be jumping out of it. Now this frees up a little bit of room here so you can do some more stuff. But ideally we also don't want to be too cramped in our breadboard. We want to give enough space. Alright, so for the tone control, we're going to jump the channel. Now this tone control is going to be a CR network. So that's going to be a capacitor and a resistor. The resistor is going to be fixed, but we're going to be able to adjust its frequency through the tone control, which again is a high pass filter, and you're going to be able to essentially swing how much bass you're rolling off. That's going to be the relationship between C5 and R8, and that control for the tone knob is actually going to help adjust that so you can dial it into taste. So we're out of C5 and we have to jump the channel over here. So we're going to grab some blue wire. We're going to jump our channel right here. Okay. And now we're going to be going into leg 3 of our cap. Our potentiometer. 1, 2, 3. So we're going to simply place that right here. Now this is something you'd actually be able to, like, one of the easiest mods for most things is a potentiometer change. Remove one, replace it with another one, see if you like it more, or if you like it less. Or maybe the taper, go from like a linear to a logarithmic, a reverse log. One of the easiest things you can do, and just let your ear be the judge here. Alright, so what we got to do is we got to bridge 2 to 1. So leg 2 to leg 1 of this potentiometer is going to get bridged with a piece of wire. So we got a blue piece of wire. We're going to bridge that here. Okay, great. Now what we're going to do is we're going to grab our resistor. For R8, we got a 2.2K. We're going to shorten our leads. We're going to jump away from this potentiometer just a little bit. Give us some room to play over here. And now we got to go to ground. A little bit of black wire right to the ground rail. And now that completes our CR network, or our high-pass filter network, so that we can adjust the low content of this Octave Fuzz filter. Alright, so that wraps step 5. Let's jump to the last step right now. Alright, so we're at the home stretch. All we have left is our volume pot, which is going to be essentially an attenuator, so we can choose how loud we hear the circuit, or how much we hear it. So, all we've got is a potentiometer and some wire for this last leg. We are in the bottom channel here, so let's stay in this side here and go right to the output. So what we're going to do, sometimes I treat the potentiometer similar to ICs and transistors, where that's the main thing around it. So we have all the ancillary parts connecting after we do something like a potentiometer first. So we're going to put our potentiometer right there so that we're pretty close proximity to the output female pin headers. So we can actually do that, and let's work backwards here because that's our goal. Let's start at the end and we're going to bring it back to connect where that output coupling capacitor was. So we're going to go right down the line. We're going to do pin 1 of the potentiometer to ground. So essentially, if we have our potentiometer minned, all we're getting is ground. If we have it maxed, all we're going to be getting is circuit, minus impedances that are happening at the end. Let's not get bogged down by that yet. So we got some wire. We're going to stretch it a little bit because we need to go from the pin, the output pin here, to pin 2. So we see we've done that from the output pins to pin 2 on this potentiometer. Awesome. So now all we have left to do is get from our output volume to the end of our circuit. So we're going to be connecting pin 3 on this output potentiometer to our little network here, which is connecting to the output capacitor. Simply going to do that with a little bit of wire. There's one. And here's 2. Now we've connected our circuit fully from the output coupling capacitor to our master volume network. Now, just like the input capacitor, this output capacitor is blocking DC while allowing AC. And again, this is going to set our master volume. So, what we've got as a recap here, we've got our fuzz control, we've got a tone control, which is going to be our high-pass filter, and a master volume, which is going to be attenuating the overall output volume of the circuit. So, now that we've built this, you guys can mess around with it. You can change potentiometers, you can change transistor types, change capacitors, pretty much change anything you want. That's the spirit of this. You know, or you can keep it as a standard Octave Fuzz. This is going to be in your green ringer style, essentially an octave smashed right between like a tone bender style circuit. So mess around with this, experiment, make it your own, and we'll catch you on the next one, and thanks for tuning in.